Okay, class. So this is 3A problem set number 24 and 42, or 30, or something. I don't know, whatever the last one is. But this is number 24. So this is asking for, if you read the directions for number 24, it's asking for the percent by mass of carbon in acetylene, or C2H2. Okay, so this is not difficult at all. You're going to need a periodic table because we need to know the atomic masses. Okay, so we take a look at our compound here. Our compound is C2, there we go, C2H2. And what I do is I put C and H, and then I use subscripts. So the subscript for carbon is 2, for hydrogen is 2. I multiply by, now this is the subscript here, and I multiply by the atomic mass. On the periodic table for carbon is 12.0. I round off to the first decimal place, to the 10th place, and then that's 24.0 there. And for hydrogen, it's very simple, it's 1.0. So this is 2.0, like that. And I get 26.0. This is the number of grams in 1 mole. What's a mole? We will talk much more about that later on. Okay, I'll do that for the next problem. So 26.0 for the total mass for 1 mole of C2H2. Okay, we're looking for just the carbon though, which means that we want to get rid of the hydrogen, find out what that is. So I take whatever the mass is of the element that I'm looking for, which is 24 for carbon, and I divide it by the total, which is 26, just like that. So that means 24 divided by 26 equals, now this is going to give me a decimal like this. Oops, come on, there we go. This is going to give me a decimal like this. I move it 2 places to the right to give me 92.3%. So 92.3% of this compound by mass is carbon. Notice I took the total mass of carbon divided by the total mass of the whole compound. I'm going to do that over and over again. I'm going to do these 3 here, and then you're going to finish up the rest of them, just like we did with the first part for 3A. So hydrogen in HC2 or HC6H7O6. I do the same thing I do here. Hydrogen, carbon, and oxygen. How many carbons and how many hydrogens and how many oxygens do I have? I add 1 more onto there to get 8 times 6 times and 6 times, there, like that. Those are the subscripts for my compound. Now I multiply by the atomic mass on a periodic table. That gives me 8.0, like that. 6 times 12.0 is 72, like that. And oxygen is 16, so 6 times 6 is 96, like that. And then I just simply add them all up. So looks like I get 176. 176. Let me just make sure so I don't screw something up here. That's 96. 176.0. Okay, that's the number of grams per mole. What's a mole? We will talk about that. So now I'm looking for hydrogen, which means the total amount of hydrogen, the 8.0, divided by the total amount of the compound, which is 176.0. So let's get this decimal like that. I move it 2 places to the right to get 4.5% hydrogen by mass. 4.5% hydrogen. Excellent. Let's keep going. I want to give myself just a little bit more room. So now I'm still looking for hydrogen, except this time it's an ammonium sulfate, so NH42SO4. So I do the same thing I did for the previous 2, N's, H's, S's, and O's. I have, how many N's do I have? 1 times 2 is 2 N's. 4 times 2 for H's is 8 H's. 1 S and 4 oxygens. I'm going to those are the subscripts. I'm going to multiply all the subscripts here by the atomic mass for each one of them. For N, it's 14.0. That gives me 28.0. For H's, it's 1.0. That gives me 8.0. And for sulfur, it's 32.1, which gives me 32.1. And for oxygen, it's 16.0, which gives me 64.0. I add them all up. 28 plus 8 plus 32.1 plus 64 equals 132.1. I'm looking for the H, so 8.0 divided by 132.1. I get 0.060, and then I round that up to a 6. So 2 places to the right gives me 6.06% of hydrogen. Okay, go ahead and do the next 3 just like that. Look up, we'll use a periodic table, either in the book if you have a book or not. Use one that I have given you, because they should all, except for the periodic table of ions, they should all have atomic mass on them. Okay, so let's take a look at the last problem. The last problem is number 32, not 42, it's number 32. If Avogadro's number of pennies is divided equally among 292 million men, women, and children in the United States, how many dollars would each have? Okay, how does this compare with the national debt of the United States, which was 7 trillion, which now it's up to like 25 trillion at the time of the writing? So let's take a look. What is Avogadro's number? So Avogadro's number is 1 mole of something. 1 mole of anything equals 6.02 times 10 to the 23rd particles. Okay, so this is, oops, there we go. This is Avogadro's number, 6.02 times 10 to the 23rd. So what does that mean? That means 6, 0, 2, and 21 zeros after that. There's 3, 6, 9, 12, 15, 18, 21. Okay, so if you gave each person of 292 million people, so that's 292,000,000, what would you get then? So let's do the math. 6.02 EE23 equals that number divided by 2.92 EE8 equals, okay, now here's what I got. I got 2.06 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times 10 to the 15. Each man, woman, and child would have that number of dollars. If we divided, I made a mistake here. We got Avogadro's number of pennies. Oh, bonehead. That's me. I'm the bonehead. Let me erase this here, because what I have to do is move the decimal place 1, 2 places in, and then that makes this number times 10 to the 21st. So let's do that over again. 6.02 EE21 instead of 23 divided by 292, 1, 2, 3, 1, 2, 3, like that. Now I still get the same, so let's do it like this. That would give me 2, 1, 2, 3. I think there's one more set of 1, 2, 3. So this would be thousands, millions, billions, $20 trillion each man, woman, and child would get if we had Avogadro's number of pennies and divide them equally among 292 million men, women, and children. Wow. So what is that? How does that compare? That means that each person could pay for the $7 trillion debt 3 times over. Could pay for the debt. Oof. 3 times over. Almost 3 times over. Because that is 20 trillion versus 7 trillion. Wow, that's a lot. So 1 mole equals that number of particles. When we're talking about moles of like element, like carbon, 1 mole equals that number of atoms of carbon. And those number of atoms then have a mass of 12.0 grams of carbon, if we're talking about carbon. Okay, if we're talking about, notice that 12 is the same number as the atomic mass on all periodic tables. Notice if I'm talking about 1 mole of particles or elements or atoms, and I'm talking about, I don't know, let's pick something else. How about potassium? That would equal 39.09 grams of potassium. So 1 mole of particles equals the atomic mass on the periodic table, and that's going to become very important. All right, good luck.